Hello, and welcome to our presentation on botnet awareness. In this project, we've created a controlled botnet to demonstrate how network systems can be compromised. A botnet is a network of interconnected devices, such as computers or phones, infected with a malware that allows a central controller to remotely manage them. These devices, often called zombies, work together to perform large-scale tasks across a network. We built our system using the BYOB framework, Python, Docker, and Tailwind. Our goal is to show how vulnerabilities in a single device can spread across an entire network, highlighting both the power and risks of interconnected systems. The functionality of our project is built around a distributed client-server architecture, where a central command and control server manages communication with multiple client nodes over a network. The process begins by generating a payload, which is either a Python script or a compiled executable, which runs on a host machine, establishing an outbound TCP connection back to the server. This setup demonstrates how persistent transport layer communications are formed, with the client initiating communication. Because of that outbound connection model, the system can operate across NAT and firewall boundaries, with each infected machine maintaining the active session, making it a node of the distributed system. The server handles multiple simultaneous client connections, highlighting concepts such as concurrency and session management over TCP. Communication is structured through the data that is sent over the sockets, enabling real-time coordination between the server and the collected clients. Now to show you how this process works. We'll first start the process by scanning for open SSH ports. This allows us to upload and run our payload script. It is important to know that this was the easiest method for us being outside the connected network. There are multiple ways to upload the malicious code. After we run the SSH command, we will see on our host machine's terminal that a connection is made. From here, going back to our web GUI, it is confirmed that a connection has been made. From this point, we have a variety of executable methods that can be ran on each bot. Some include Bitcoin mining, DDoS attacks, persistence, key logging, screenshots, and remote access Trojans.
So why is it important? Every machine in here is now a part of our botnet. And what we can do with this is that we can exploit all of their combined computing resources and power to do any kind of malicious act or any act in general that we would like to compute.
We spent a lot of hours debugging libraries, external tools, capturing data in our dashboard. First challenge was just getting the application to actually run. The BYOB web GUI hadn't been maintained in a while since the project was originally started 8 years ago, with the most recent updates being 2 years ago. So several dependencies were outdated or incompatible with newer versions of Flask. So we had to identify which imports had changed, update specific function calls, and patch the virtual environment before the server would even start. And then the second challenge was we kept getting connection timed out errors during payload executions when we were trying to execute the payload onto the target machine. And this was resolved by migrating the virtual environment from a NAT network to a bridge adapter, allowing the Linux C2 server and the Windows 10 victim virtual machine to communicate directly via their local IP address on the same subnet. Then the third challenge was to actually get the bot connection to actually appear in the dashboard. Even after the payload compiled successfully, the Windows VM couldn't reach the Ubuntu server because of VirtualBox not networking. We solved this by setting up port forwarding on the host machine and hard coding the host's local IP address into the C2 configuration of the payload so the client knew where to call it back. For our results and outcomes section, our biggest accomplishment we'd say definitely comes from getting it to all work. All known documentation for this repository states that the C2C does not work on Windows devices, so getting a WSL integration was a good sidestep to get around the issue. But another part we're proud of is our contribution to the repository. Adding another control method, we created a propagation method that uses ARP scan or a fallback ping scan, depending on the OS, to all the available networks an infected machine has access to, then stores all the reachable IPs onto the currently connected network. From there, it will then try to create a SSH connection, presumably with no extra security measures since they are all in the same network. The final step is a recursive function call on each connected IP's available IPs. If there is one the device does not have access to, it is added to the list. The base case runs until each node and its child node have been reached. When a connection is made, it will check for Python. If Python is installed, it will transfer and execute the Python script. If not, the goal is to host the exe file and transfer it based on the stored IP's OS using the assigned dictionary value. But we did not have time to implement this level of feature. When we started, we didn't anticipate how much work it would take just to get it working. It would be a different story if we just had a bunch of setup, but actually changing files, rewriting code, editing the payload generation to match IP configs, and spending hours just debugging were different from actually setting up, running, and expanding our project. However, overall, doing these fixes and debugging, we learned how this project worked, figuring out how to properly set up the container and get it talking with the outside world. Actually learning how to code at the network and OS level. For our future applications, the technical skills throughout this project, specifically in networking, command and control architecture, and system level resource management, are directly transferable to lots of high impact fields. One example would be cybersecurity defense. Understanding the mechanics of botnet propagation and communication is the most effective way to build IDS, so intrusion detection systems and honeypots.
Looking back on the project, we can definitely say that despite having its moments, overall it was a really fun experience. Dealing with configuring firewalls, writing malicious code, and ensuring complete and total isolation provided an absolute masterclass of a project. Making this project work was so rewarding after countless hours of what seemed like endless debugging. Moving past theoretical concepts to practical applications lets us know that what we did wasn't a waste of time. Thank you for watching. I'll and I'll